Hi there. We're going to go over the article talking about anchor intervals. And the first step into understanding what an anchor interval is to first bring the idea of interval, which we defined in previous article talking about numbers in a cyclic system. And we're going to bring that to notes. So, just as a reminder, where we were at was that we had figured out that the interval between two numbers was equal to y minus x. Now, we want to bring that to notes. So those x and y's were numbers, but if you remember d, for example, we reference by 2 star, right? And for example, a would be 9 star. So the interval between 2 star and 9 star, which are notes, is going to be equal to the same thing, 9 minus 2, which is 7. So pretty much what we've just defined here is that between any two notes, in note I use the star, is equal to y minus x, right? So we've just extended that idea of an interval that was between two numbers to between two notes. Now, if you remember, we were also talking about like numbers which were negative and stuff. But in the standard system, the way they talk about like these sizes is using this positive system. So just to make that conversion easier, we're also going to use that standard system. So we're going to focus on the positive versions between two numbers, even though it might be easier to say the negative version since this is a smaller number. So yeah, anyways, we were talking about D and A, right? So let's just go over it quickly. So like, if someone says, what's the interval between D and A? Well, D, A, that's equal to the interval between 2 star, 9 star, and that's equal to 9 minus 7, which we've already talked about, 9 minus 2, which is equal to 7. Then we could go on our table, and that's a perfect fifth. So the interval between D and A is a perfect fifth. So that's how we can use that table. Now, what are anchor intervals? Well, we've already talked about these, but it was in our first lesson, and we didn't really call them anchor intervals. We just said, let's consider a note as an anchor point. So, for example, if we have 8 star, and then the note 9 star, it's considered as 1. And the reason why we considered it is because we have to add 1 to 8 to get to 9, right? So it's how far you need to go from one to the other to get that number. And when we specify a note via its anchor interval, we don't write an asterisk on it. And just to be explicit, an anchor interval of a note is the interval between the anchor note and the note that we're considering. And writing the word anchor interval over and over will take up a lot of space. So we're just, whenever you see the two letters AI, that's referencing an anchor interval. So the anchor interval between the note 2 and 4 is going to be the interval between 2 and 4. Because if that's our anchor note, and that's just another note, then it's going to be this, just 2. So yeah, we've gone through examples, we know the definition of that now, and so we may as well make it as efficient as possible. And if you remember in our cyclic system article, then there was a fast way to compute the interval. So just remember, when we're thinking about stuff in a circular fashion, if we have a goal, it's always better to go the short route. So that'd be the long route. This is the short route. So the reason why we do this is because in general we want to minimize our movement, right? So the way we can talk about numbers in this idea is by considering the short version of it. So let's say that was 7, right? The long version of 7 is just 7 itself, but the short version of 7 is minus 5, meaning that we only had to jump 5 times to get there. So that's saying the small representation is minus 5. So the small representation idea is going to come into play a lot now, because of course now we can take intervals between two notes, and if we have the anchor note and then some other note, well, the interval between them is n minus a, right? But that's the same thing as n minus the small version of a, the small representation. And so we'll be using small representation a lot. And for example, let's do this example. So we set our anchor note to be 8, right? Now, we know that whenever we consider another number, so let's take another note. So if our other note was 3 star, right? We want to know that note's anchor interval, so we do the interval between these two numbers. Now we know we're going to do 3 minus 8, right? But 8 is not the small version, right? So what we really are going to do here is we're going to use the small representation, which is 8 minus 4, which is the same thing as adding 4, which gives us 7, right? So you can see the small representation of a number becomes useful when we're talking about notes eventually. So when you set your anchor note, what you want to do is just consider, what is the small representation of that number? Well, it's minus 4. And you keep that in mind, because whenever you see another note, you know, okay, so I'm going to be, whatever note I get, eventually along this process, I'm going to be subtracting, which means, oh, that turns into adding. So in reality, the operation that happens here is a plus 4. So whenever you see a new note, so let's say we get the note 2, we know this whole process is just going to boil down to adding 4, and then we'll get 6 as our anchor note. And that makes sense since the anchor note of 3 was 7, so the anchor interval of 2 is 6. So knowing what the small representation is before you start is going to be really useful. And then also just considering this process, you get the small representation of your anchor note's number, and then you use that to compute the interval quickly. And now that you know how to do that, you want to get it down like faster, so you can figure out what that is quickly. And I've built a web application for that, and just go under the web applications section and start playing around with that. There's a video which explains how it works, so that'll help you out as well. And yeah, hopefully you enjoyed this video.